We are going to look for a solution to a system of linear equations. I have a little hint up here. If you know what the term consistent and independent mean in a linear system, then you know that there is a solution for this, and there's exactly one solution for this. So there's no tricks in this. There's not going to be no solution. We're not going to get infinite solutions. There's a unique solution for this. So let's look at how we go about doing this. In this, I'm going to use the transitive property to help me find a solution for this system. What I'm going to do is I'm going to take the first equation here and I'm going to solve it for y. Then I'm going to take the second equation and solve it for y. And then I'm going to set each of those expressions equal to each other since they both equal y. And this is just a little bit of transitivity from the real numbers that we're using to make this happen. So I'm going to go ahead and I'm going to number these 1 and 2 just top to bottom order, and then pull them off to the side, and we'll solve each for y. There's a couple of things that we can do with this equation here. If you notice that each of these have a common factor in them of 3, you can go ahead and factor that out and make your calculations easier. But let's pretend that you haven't realized that there's a common factor, so we'll go ahead and work through this as is, and then if you do recognize that there is a common factor there, you can go ahead and divide that out and make work a little easier for you from the get-go. So I'm going to move 3x to the other side by subtracting it away from the 3y term. I want to ultimately have y by itself over here on the left-hand side. So after I subtract this out, we will deal with that 3 that's being multiplied by the y. Once we've subtracted 3x from both sides, we're going to divide everything by 3 to get this y by itself. Alright, now I have y equals something, and we'll go ahead and pull down the second equation and work with it. The same process, we want to solve it for y. I've subtracted x from both sides to get this y by itself, but y is negative in this equation, and we can't leave it like this. It's tempting to leave it like this, or maybe even ignore the fact that it's negative, but we have to do something about this. What I'm going to do is I'm going to multiply everything by -1. Since a negative times a negative is a positive, that will get me my positive y here. So everything multiplied by -1 will give me y equals x plus 12, and that's a nice looking equation. So now I have y equals negative x minus 9, and I have y equals x plus 12. If this y is really the same y, then that means that whatever this is equal to whatever this is, and that's by transitive property of the real numbers. So the next thing I'm going to do is I'm going to set the negative x minus 9 equal to x plus 12. And this gives me a one variable equation to solve. So I'm going to solve this for x and see what I get. So I'm going to bring x terms over to the left-hand side and the integers over to the right-hand side. So I'm going to subtract x from both sides. So I have negative 2x equals 12 plus 9. So I have negative 2x equals 21. I need x by itself, so I'm going to divide both sides by -2. So I get a fraction for my solution here. I have x equals negative 21 halves. So this x is related to the original system, and that for both of these to be true simultaneously, this x has to be negative 21 halves. But if we substitute x into here, we still don't know what y is. So that's our next object, is to find out what y is. And this is less involved since we already know what x is. Just pick whatever your favorite of these two equations is to work with and substitute x in for the x there, and we'll have a one variable equation. I've chosen to work with equation 2 from the original problem, and I've substituted my x in for the original x. And so now I have a one variable equation where y is my unknown, and I'm just going to solve this for y. So the first thing I'm going to do is add 21/2 to both sides so that I can have this negative y by itself. So I have negative y equals -3/2, and again, we need to have this y to be positive, so I'm going to multiply -1 by both sides here so that I have y equals 3/2. So now I've found an x and a y. So the solution to the system is the point -21/2, 3/2. This is my x and y coordinate, and geometrically what this means is that this line and this line, when graphed on the same Cartesian coordinate plane, will intersect at this point, and that's the only intersection point that you will see.